Relational Algebra 2. We'll discuss this lecture today. Then we have completed the Relational Algebra 1 and you have a good basic understanding about the Relational Algebra notations as well as the meaning of these notations, and also I explain how to retrieve the relation or data from the relations using this relational algebra. So let's discuss the second part of the relational algebra, part 2. So under this, the relational algebra operation with set theory, we have discussed the binary relation operations and aggregation and grouping. Basically, I am going to focus on these binary relations. Actually, we have discussed in the previous lecture. Aggregation and grouping is very, very important. We'll try to discuss these two. So here you could understand these notation symbols as well as the meaning of the symbols. Project means select the rows, select the columns of the attributes. Row means select. Rename also you can understand. You could understand the previous lecture. Union, intersection, assignment also understand. Today now we have to discuss basically these things: Cartesian product, join, left outer join, right outer join, and full outer join, and semi join of the relations. Basic relational algebra operations, actually I explained previously also. Relational algebra divided in various groups. Unary operations, you know that the meaning of the unary is only it can be used only one relation: select, project, and rename. And set theory operations, then binary operations are there, that is union, Cartesian product, and set difference. We use the binary relational operations. And set theory operations are union, intersection, different, and Cartesian product. These are called the binary relational operations. So binary relational operations actually join, division, union, intersections, difference, and Cartesian product. So union, let's say the union. In the basically, if you know the set theory, union is symbolized by the U, the U symbol. It includes all tuples that are in the table A or in a table B. That is, the union compatibility must be there, as I explained in the previous lesson. Without the union compatibility, we cannot union two relations. It also eliminates duplicate tuples. So set a union set B would be expressed as the result assigned to the result is assigned to a separate one or temp or A union B. For a union operation to be valid, the following condition must be there, as I explained before. The A and B must be the same number of attributes. A and B must be the same number of attributes. That means same number of columns. The degree of the relation is same. In another word, attributes domain need to be compatible. Attribute domains also need to be compatible, and duplicate tuple should be automatically removed. When you are going to combine, if there are any duplicate tuples, it will automatically remove, and you can find the atomicity, union, only one instead of two or more. Let's try to understand by using simple example. S1 and S2. You can see the same number of tuples and the attributes also the same, and if you want to union these two, S1 union S2, in such case you can get this 31, you can 31 SID 31 you can find in these two tables. In such case you can get only once here 31 and 3 4 7, but you can find the 6 because 31 is the same in two relations. So we'll try to understand the practical usage of this union. For an example, if there are two student tables, so that if you want to create one instead of these two, and it has some due to some reasons, those places are maintaining two student tables, but sometimes you can find the duplicates, and maintaining the two tables will be a different. With having these two tables, you may have some you may have some difficulties. If you update one student information in one table, but you forgot to update the student information, that particular student information in the second table. In such case, inconsistency of the data will be there, so that if you union these two tables, you can get the unique keys, so unique tuples, so that you can easily maintain table 1 and table 2, column 1, column 2, and here both tables may have the same column, then you can only one, and you can have this 1 1 1 2 1 3 1 1 1 2 1 2, also you can find 1 3, only unique ones. So intersection means the common tuples, common relations can be found. A intersects B define the relation consisting of a set of all tuples that are in both A and B. However, A and B must be union compatible. These two are union compatible. Before getting the union, you can get the similar data in the both tables. In such case, you can get this union. From this union operations, you can get the similar tuples in both tables, and this is the visual definition of this one, and intersection actually get the common tuple. So the common tuples in both these tables, but make sure that A and B are union compatible relations. Here intersection, as I told you, the 31 can be seen in those two tables. When you use the intersection operation, you can get the 31 and 58. 31 and 58. Both tuples are in the both relations. In a relational algebra, operations are complete. Actually, 5 project, select, union, difference, and Cartesian product. That is, other relational operations can be derived from the set. From here, we can derive this one from the set. R intersect B equals R union S minus, within bracket, R minus S union S minus R. Actually, we can this is actually, we can prove this one using the set theory, and R union S is R union S minus R minus S union S minus R. Also, commutative operations means R union S equals S union R. There is no any difference because R and S are union compatible relations. R intersect S also is similar to the S intersect R. This is commutative. Low associative operations are R union S union T equals to R union S within brackets R union S union T, and within bracket R intersect S close the bracket and intersect T equals to R intersects within bracket S intersects T. This is called the associative operations. Set difference. Set difference actually the result of the operation denoted by R minus S is a relation that includes all tuples in R that is not in S. All tuples in R but that is not in S. So then sometimes without an example you may find some difficulties to understand this. Let's see. Let's try to understand using an example. Attributes names of R has to match with the attribute names in S. The two operand relations R and S should be either compatible or union compatible. Compatible or union compatible, and it should be defined relation consisting of tuples that are in relation R but not S. Let's try to understand using these simple examples. So you can see this previous S1 and S2 relations. Set difference. S1 minus S2. S1 minus S2. All the tuples in R but not in the S we can see. That means S1 minus S2 we can find 31 and 58 here, 31 and 58 here. So 22 cannot be seen in this one. That means when you go to the definition once again, the result of the operation denoted by R is a relation that includes all tuples in R that not in S. All tuples in R that not in S. So here all tuples in R but not in S. But there are some different tuples which is not in S1, but you are not going to display this one. But S2 minus S1, that means you can find all tuples in S2 but not in S1. That is 28 and 44. 28 and 44 is not in this one. So this is the difference between set difference. The Cartesian product. Cartesian product in a DBMS is the operation used to merge two columns from two relations. The merge means get together two columns, that is columns are the attributes from two relations. The two relations, as the Cartesian are the binary operations. Generally, a Cartesian product is never a meaningful operation which it performs alone. So that you having this what we call using this Cartesian product only, you can't get the meaningful operation. So that, however, it becomes the meaningful when it is followed by other operations. So that if it used by itself, you can't get any meaning. So this must be used with another operations in order to get the meaningful output. It also called the cross product or cross join. Cross product or cross join. Let's see. Instructor, administrator. Simple example. Name and number. Administrator, all the admin and number is there. You can see name is Don 3412 Nell 2345. So this is the admin positions. Don is the dean and Nell is the secretary. So when you get the Cartesian product instructor into administrator, you can find this one. Name and number, admin and number. You can get these two. So you can't get any what we call any meaningful idea from this one. So you have to use this one with another set operation. So extract tuples with a selection operation. So select number equals number from instructor and administrator and assign to the temp. So select from this Cartesian product you earlier get, select number equals number. The select number equals number, you can see here this one. Name, number, admin, number. You can see this one also. Weed out attributes with the projection operation. Project name, number and admin from this temp. Name, number and admin. So there are 2 times you can find name, number and admin. So project only these 2. Likewise, you can get the Cartesian product, and by combining the different operation, you can get the meaningful output from the Cartesian product. And however, there are some common requests that cannot be expressed using the relational algebra. So this is also you have to understand very clearly. What are those? For an example, how many students are there in a university? How many students? So, but in a relational SQL, you can use the count keyword for that one. But therefore, we extend relational algebra with the set operation, outer join operations, and aggregation and grouping. So, therefore, as we cannot do this one, therefore we extend relational algebra with the set operators, outer join operators, and aggregation and grouping operations. So you know that join, division. Let's try to understand this join. Actually, join also we can find there are 3: full join, left outer, right out, and full outer join. We will have to discuss under these join operations. The join operations, actually, the join operator is the popular operation in relational algebra used to combine information from 2 or more relations. So we can write the join operation as R join with S. You have to give the join condition and equals select join condition R into S. Cartesian product. First get the R and S Cartesian product and select the join condition. This is similar to this one. Join arises much more frequently in practice than plain cross products. So join arises much more frequently practice. but than this, when you compare this join and the Cartesian product, we can frequently find this join rather than Cartesian cross product. So let's try to understand in detail about this join. Join can multiply relations, algebra operators, to obtain the relations from a relational schema. Let's try to understand this simple example. Project means select the attributes, student info, full name and M department we discussed in the previously. If you could remember this one, and then here the name major and select GPA is greater than 3 from the student. Try to understand this very clearly. Rename student. First of all, get this one. Select GPA is greater than 3 from the student. In such case, you can get all the tuples of the students whose GPA is greater than 3. So then get all the tuples, that all the columns, but you want to select only name and major. Then project, you have to use the project name and major only. From this one you select all the columns, but you want to restrict of this one, and these columns must be renamed, and rename student info, full name and M department, full name and N department. And we can write in this in 3 steps. One is select, one project from select, and you can assign this one to the temp, and then you can write instead of the temp, these are the temp part, you can write student info, full name and major. Join operation is essentially Cartesian product followed by the selection criteria. Join operation also join various related tuples from the different relations. So when you see this expression, you might think that is a very difficult one, but when you read from the right side, you will be able to understand very clearly, and in that time you will realize how this is so simple. This is select, actually select all the tuples whose GPA is greater than 30 with the all attributes. Then from that only you want to select the major and name and major. Then select these two attributes from the student whose GPA is greater than 3, and you are going to rename this major and name and major to the student info. That is the, instead of the student info, the relation name and full name, and the, instead of the name you can write the full name, and instead of the major you can write the M department. Here are the join types of join operations. Join operations: natural join, outer join, equijoin. There are 3 types. The outer join also you can find the left outer join, right outer join and full outer join. So these are the types of the join operation you have to understand: natural join, outer join and equijoin. Outer join, actually there are 3: left outer, right outer and full outer join. Natural join actually earlier we discussed, and the natural join is a set of tuples, all combination in R and S, that are equal to the common attribute names. It is denoted by this one, this notation, join notation. Natural join actually denoted by asterisk removes the superfluous attributes from the result. Natural join requires that the join attributes have the same name. This is the attribute name must be similar. An example, as same before, the rename operator can be applied before joining the operation. Sometimes you can apply if there are difference in the names. You can you can use the rename operators to apply to get the names consistent. Let's use the employee table and salary table to understand the natural join. We'll try to understand the employee and the salary. Employee is there. Here employee code, employee name, employee code, salary. Natural join, when you use the join, you can get employee code, employee name and salary. 101, 2, 3, 101, 2, 3. Names are Stephen, Jack and Harry. Salary is 50,000, 30,000 and 25,000. This is called the natural join. You can find these are similar attributes. Another example, actually employee and department. So find all information on every employee including their department info. The find all information on every employee including their department, the department info where the employee works in office, numbered less than the department main office. What does it call? So employee including their department info, the department info, department info where the employees work in an office. The employees office number is there here, 400 to 220 employees works in the office numbered less than the department main office. The department main office numbers are there. Here you can find 404, 200, 200, 404 and 501. Less than the department main office. Less than the department main office. That is, you have to get the employee and the department. In that you have to give the condition here. Office is less than main office. Office is less than main office and department equals department. Department equals department. Office is less than main office. The office is the office number is less than the main office is the main office number. And we can get the result as office is less than main office. Here 400 is there. Then Sumit and department equals department. CS. Here department equals department. CS. You can get the first one, the Sumit 400 CS and CS 400 this one. Next, likewise we have to get the result, this result. So given statement must be understood very clearly, then you can convert it into the Boolean expression like that. Next one, get office is 220 but main office is 200. That is not satisfied this one. And this one, green, Main of is 200, this is 160. Yes, you can get that tuple. And 420, 400. That is also cannot get 500 and 501. That is, we can get Smith also to the table. So this is called the natural join. Next, try to understand the outer join. Outer join actually, join operation takes away the non-matching tuples. Join operation take away the non-matching tuples and also join attribute which null values are also eliminated. Null values also not going to get. Some queries requires these tuples. Outer join has 3 tuples. Left outer join denoted as this one, right outer join denoted as this one, and full outer join denoted as this one. You can see left outer join, left side is open but right side is closed. Right outer join, right side is open and left side is closed. Full outer means both sides are open. We'll try to understand one by one. Left outer join. A join operation B. The left outer join contains the set of tuples of all combinations in A. The all combinations in A, but that are equal on their common attribute names. Don't worry, I will explain in the example, then you can understand very clearly. In the left outer join, tuples in A have no matching tuples in B. Tuples A join the tuple A have no matching tuples in the B, and ensures that all tuples in the relation A are present in the relational set. All tuples in the relation A are present, not the B. The tuples in the A without matching the tuples B are filled with null values for B's attributes. I will explain like this. Left outer join. Get this one. Employee name, street, city. Employee name, branch, salary. Left outer join, and if employee left outer fact works, then you can get all the attributes in A. Ram, Sham, Ravi, Hari. Ram, Sham. This is Kumbla is there, but that is not in here. We can find all the all the tuples in employee, like here Ram, Sham, Hari, Ravi, and Ravi is not here. Others have the place Ram, Civil Line, Mumbai, in Infosys 1000. You can get this one. Sham also we can find Park Street, Kolkata, Park Street, Kolkata. Wipro and salary is 20,000. Harry also has Harry. Nuran Negre and Hyderabad, TCS and 50,000. Ravi has these two, street and city. Ravi name, that is street, you can find MG Street. City is Delhi, but you can't find the similar attribute for this one. Then you can fill from the null values. All the tuples in the left side can be seen, but if that is not in the right side, you have to fill with the null values. This is the rule for left outer join. Then you can understand the right outer join very clearly. Right outer join, left outer join contains the set of tuples, all the combination in A and B that are equal to the common attributes names, and write out a join tuples in B have no matching tuples in A. Also you can find reverse of the left outer join retrieves all tuples B and null values for the attributes A of non-matching tuples in B. This is the simple example. The previous example let's get. And employee write out a fact works. Then in such case we can find these all are in Ram, Sham, Kumba and Harry. Sham, Harry and Kumba. But Kumba is not here. Then it has HCL and 3000, HCL 3000, and as not having the similar one in the employee, you can fill it the none value. This is the right outer join. Then full outer join is the combination of these two. Full outer join. The full outer join A condition B, full outer join is like the left or right join, expect all the contents, all rows from both tables. All rows from both tables must be there. Full outer join tuples in A have no matching tuples in B, and tuples B in that have no matching tuples in A in the common attribute names. That means ensure that all tuples of A and B are present in the result. Likewise here you can find employee full outer fact works. You can find all these things. Ravi is here but no matching tuples in fact works. You can fill it null. Kumble is here in fact works relation but no matching tuple in the employee. You can fill it the blank. Likewise, this is called the full outer join. Then I explain the natural join, then outer joins. In that outer joins also left outer, right outer and full outer join I explain. The equijoin. Equijoin actually tuples whose join attributes are null to do not appear in the result. The tuples whose join attributes are null. If the join attributes are null, do not appear in the result. Equijoin actually, in equijoin, equality actually is the only allowed comparison operator. Instructor and administrator. Here, when you get the Cartesian product of join number equals num, administrator. Number equals num. Then you can say the name number admin num, don number is this one, dean and similar number. The here, but when you consider the Neil and secretary, you can find the different numbers. 2314 4123. That is the not satisfy this condition. This is called the equijoin. Then aggregation and grouping. Aggregation and grouping also will try to understand. The following set aggregate functions are introduced. Count. Count the number of tuples. Sum. Calculate the summation of values. Average. Calculate the average. Minimum and maximum. Max values and the mean values. So aggregation and grouping, for an example, count the number of employees in the company. No grouping actually. Here the symbol count the number of tuples in employee table. That means number of tuples in count ID, number of tuples. Count the number of employees and average salary of each department. Here we can see department number, count ID, average salary of the employee. And count the number of employees and average salary of each department, average, then get the summation of the salary and divide the number of employees work in that department. So this